Have you ever wondered why it's harder to change the direction of a spinning object than a stationary one? Well, the answer lies in a fascinating concept in physics called rotational inertia. Picture yourself trying to spin a bicycle wheel. It's pretty easy, right? Now, imagine that same wheel but with weights attached around the rim. Suddenly, it becomes much harder to spin. This is because the weights increase the wheel's rotational inertia. Rotational inertia, often symbolized by the letter I, is a measure of an object's reluctance to changes in its rotation. It's a bit like the stubborn cousin of the inertia we experience in our everyday life, which is an object's resistance to changes in its motion. Two main factors determine an object's rotational inertia. First, the mass of the object. The heavier the object, the higher its rotational inertia. Second, the distribution of that mass around the axis of rotation. If the mass is concentrated far from the axis, like the weights on our imaginary bicycle wheel, it increases the rotational inertia. To get a bit mathematical, the rotational inertia of simple objects, like a hoop or a disc, can be calculated with the formula I equals 1/2 mr squared. Here, I is the rotational inertia, m is the mass of the object, and r is the radius. But for more complex shapes, we need to bring out the big guns, calculus. Rotational inertia isn't just a neat party trick for physics enthusiasts. It has real-world applications in a range of fields. In mechanics, for instance, knowing an object's rotational inertia can help calculate the torque, that's the twisting force, needed to change its rotation. In engineering, it's vital for designing rotating machines like motors, turbines, and generators. And in sports, it helps analyze the performance of athletes in disciplines like gymnastics and figure skating. To summarize, rotational inertia is a property that measures how resistant an object is to changes in its rotation. It depends on both the object's mass and how that mass is distributed around the axis of rotation. The greater the mass and the further it is from the axis, the greater the rotational inertia. So the next time you find it harder to spin a weighted wheel than an unweighted one, you'll know it's all thanks to rotational inertia. It's yet another reminder of how the invisible laws of physics shape our visible world.